neuroscientist. I grew up in Brazil, and then when I finished my PhD, I moved here to the United States to study how large populations of brain cells interact to each other and how they generate behavior. That's the business of the brain. And the more I got into this, by developing a new technology to listen to hundreds, almost now 1,000 neurons simultaneously, and trying to decode the messages that these brain circuits produce, the more I realized that we could create a variety of new ways, not only to study the brain, but also to treat neurological disorders that range from paralysis to Parkinson's disease, epilepsy, and perhaps even psychiatric disorders, because we discover a new way to interpret how the brain operates. And for the last 23 years, that's what I have been doing, trying to discover the basic mechanisms of how the brain operates, and also through a paradigm that we created that became known as brain-machine interfaces, trying to expand the reach of the brain beyond the limits of our biological body. I think is a step before that. Right now we are trying to interpret brain signals, large-scale brain activity, in a first step to try to restore functions to patients that have lost the ability to move or to sense objects. Just in last October, we published a study where, for the first time, we were able to make monkeys control, just by thinking, a virtual body, virtual arms that were touching objects in a virtual world. And these animals not only were able to control this arm to explore objects, but they were actually able to feel what that object, the texture of that object. And so we created a bidirectional dialogue between that virtual body and the animal's brain. And by all measurements, the animals interacted as if it were, their own arms, not a virtual arm, touching an object. So with that in mind, we are hoping that we will be able to use brain activity to restore full body mobility in patients that are paralyzed, severely paralyzed, by creating a exoskeleton, a robotic vest that these patients will be able to wear from the neck down, and control the movements of that vest that will carry the patient's body that is now paralyzed, just by the activity of the patient's brain, combined to a series of robotic systems. So that interface is what we are capable in the next few years to achieve. But there are other experiments that we are performing now that extend this to other domains. But the word artificial intelligence has a lot of baggage. It has a lot of history that goes into the opposite direction, in the sense that people thought that they could use computers to reproduce human cognitive abilities or human skills, mental skills. And it turned out to be a much more difficult task than people thought. And I actually believe that with the current architecture that we have for computers, all computers are Turing machines, basically. Impossible to reproduce human cognition. Human cognition depends on a variety of factors, including the type of evolution that our brains underwent to become what they are, and it also depends on the emergent property biological hardware that we cannot simulate in computers. Kind of architecture that we have so far, it will be impossible to reproduce a human brain into a computer. 10 years ago, we decided to take to Brazil an idea of using science, state-of-the-art science, as an agent of social transformation, not of economic development only, but of social transformation. Use the scientific method and all the very interesting things that science brings to our lives as a potential way to galvanize the social development of underdeveloped communities, very poor communities in the northeast of Brazil. So we chose the corner of Brazil, the northeast corner of Brazil, in the suburbs of a city called Natal, that is the northeastmost point of Brazil, pointing towards Africa. It's the closest point to Europe, to Africa, and to the Americas. And we decided to establish there a brain research institute, a state-of-the-art brain research institute that had, in addition to the mission of doing research, like I do here in the United States, to actually take science and create a science education curriculum that would be the basis of a new education program in the region. And this education program that we call Education for Life, it starts in a clinic, in a women's clinic, with the prenatal care of the mothers of our future students. So as neuroscientists, we know that a critical period for human development occurs when we are still into the womb of our mothers. That's when the brain is being formed. And if you are not acting there, and to prevent all sorts of things that can happen during that period, that human being is not going to be born with the full neurobiological potential. So we decided that to actually create an education system that would be complete, we had to intervene first on the prenatal care. Then we created for the children, for about 1,000 children of that region, that is one of the most poor regions of Brazil, a curriculum, a science education curriculum that they can take on the opposite period of the public school system. Because in Brazil, there is only 5 hours of public schooling. So the kid either goes to school in the morning or in the afternoon. Well, we decided to create a full-time schooling for those children. So in one period, they go to the regular public school, and the other, they go to schools that we created, that are basically based on laboratories. And they go to that school, and there is no class, there is no theoretical class. They basically learn science by doing science. And we started with children age of 10 to 15 in 2007. And for the past 5 years, we have been tracking these kids and how they perform after they go through a 3-year period of this science education curriculum. And we notice an explosion in that region. That region has the lowest public school ranking in the whole of Brazil. Brazil has more than 5,000 towns, and that town and that state is ranked at the bottom of the Brazilian charts. But our kids start climbing this system, and in their performance, both at the school and the national tests, they start basically getting at the level of the best schools in the country in just 5 years. Another very important thing is that in that region, after kids finish the first 8 years of schooling, when they go to the high school equivalent in Brazil, about half of these kids basically don't go to school. They disappear. They go work, or they basically drop out. It's about 56% dropout rate, the average in Brazil for high school. And in that state, that rate reaches almost 80%. Well, our kids, the dropout rate was down to 2%. So we are able to basically awaken in these children the desire to continue to learn, to continue to study, because they realize that learning can be really not only important, but can be really fun, can be something that you want to do every day. And it was this science education program that got the attention of the Brazilian government to what was happening in that part of the country. And now basically the federal government, after analyzing the results of these thousands of children that went through this curriculum, want to take this curriculum to all over Brazil. So we are basically going to discuss now with the Minister of Education the possibility of taking this curriculum to 1 million kids all over the country, and to transform science education into a priority of the next decade in Brazil. So with a little experiment, started with just neuroscientists trying to contribute to social development, we showed to Brazil, and this is very popular in Brazil, everybody knows about it, that science can be a powerful contributor to the transformation of the education system, and at the same time, the transformation of the entire range of social problems that we still have in Brazil, particularly in that region of the country. I think that my dream, I have several dreams, but at the scientific level, the dream is to be able to complete this journey that I started 30 years ago. When I went to, I quit after I finished medical school. Instead of being a clinician, I decided to go and get my PhD and become a scientist. I always dream about the possibility of doing something that would benefit millions of people. And we are very close now. There are 30 or 40 million people in the world suffering from some sort of neurological disorder that produces a devastating kind of body paralysis. And as you can imagine, that changes not only the life of that person, but the entire community around that person, the family, the friends, because it's a devastating thing to be paralyzed. So we are getting very close to a moment in which all the basic science that we did and other laboratories around the world did for the last 30 years may converge in technologies that may help these patients in a very meaningful way. Of course, there are things happening that are not as good as we desire. There's always people that want to take it the fast track and make money out of this, and then you see things that are just stunts. But the reality is that the field has evolved in these 3 decades, and concretely, there is a chance in the next 5 years or so to produce things that will help millions of people. So that's one thing. The other thing in Brazil is to see these millions of kids become enamored of not science itself, but the act of learning. Because a lot of the problems that we have in Brazil and in the world would disappear if we just could have a chance to get kids or children a better chance to learn, and a better chance to learn about the other children in the world, and they would soon realize through science and through education that we are pretty much all alike, and these differences that we try to create between us based on all sorts of little things are meaningless. We are part of the same species, and I think through education and through science we could get a lot of problems solved, because people will realize that we all have the same fears, we all have the same ambitions, we all have the same desires, and by knowing more about the brain, I think we would know about much more about human beings, and that would be a major contribution of science to humanity. And finally, I have a dream of still being alive to see a world that is based not on the benchmarks that we use today, basically money, but a world that is based on our ingenuity, our ability to transform things for the good, our ability to build amazing things at all levels, at an artistic level, at a scientific level, at a social level. I keep thinking the amount of energy that we spend doing absolutely useless things, and how much that energy could be catalyzed or galvanized to do things that could literally change the way we live, and So I still believe that there will be a moment where we are going to, by education, by a massive education, realize that we are wasting a lot of our time on things that don't matter, while we could be using our intellectual energy to really improve the life and the livelihood of millions of people. Certainly, there has to be some sort of everything that we do depends on the kind of brain that we have. Our political system, our economic system, our social interactions all derive in some way or another from the kind of biology that governs our brains. So this common attitude of staying put and not moving, not changing, certainly has to be a property that derives from the kind of brain that evolution produces for us. But at the same time, part of our species, part of our culture is to look for the unknown, for the different. We do have a significant portion of our species engage on activities that are different from the mainstream. Like art is a very powerful form of expression, but is also a powerful form of exploration. We explore colors, we explore shapes, we explore sentences, sounds, and science to me is, I always believe that science is also a type of art. The really great scientists that I met over the years, you would call them artists, because these guys, instead of just following the mainstream, what most scientists do, scientists are very conservative too. But the great ones, they escape this attractor, and they look for new things. They look for different ways to look at a problem. They look at different solutions for a problem, and they look for solutions that nobody thought before. And these are the ones that make the difference, in my opinion. So there's a huge tendency these days to train scientists to be almost like technicians. They specialize in a particular instrument or a particular domain of knowledge, and to a point in which my advisor used to say that we are getting to a point where we are going to be producing people that know everything about nothing, because they're so specialized that they cannot talk about more than one subject. I saw that during my career. But the ones that made the difference, the scientists that I met, and the scientists that I know of that made the difference, were the ones that escaped this motif and tried to combine ideas from different fields and tried to come up with original solutions. And I think that's what we need to multiply in the world. And that you can only do by education. Our public education system was created to serve the Industrial Revolution. So you needed people to learn to do basic skills and to repeat and to obey orders. Basically, that's what our public education system is based on. But that has changed. Has changed. We are, 150 years removed from the first public education curriculum that were introduced in England and then in the United States and all over Europe. But that was based on the notion that you needed people for the marketplace. Well, now you need people to revolutionize the marketplace. You need people to be trained to think, to be audacious, to dare, to create new things, new industries, new activities, new ways of thinking about the world. And our school system cannot produce this kind of people. The people that escape the school system by doing all sorts of different things while they're in school, those are the ones that are changing the world. But we need more of those people, and we cannot produce more if we keep the same education system that we have inherited from the industrial age. The model that we used for this program in Brazil and that I have used in my scientific career is a Brazilian guy called Alberto Santos Dumont, who was actually the first guy who flew an aircraft that could be controlled by man. And this is well known in France and in Brazil because he flew in Paris with a dirigible. He created the dirigibles. And in 1901, in 19 of October of 1901, he actually took off from the Bois de Boulogne and in this dirigible, and he went around the Eiffel Tower to prove that he could control the balloon. He created all sorts of aeronautical tools, like the wing, the propeller, the stabilizer, the vertical and the horizontal stabilizer, and he created a system to allow him to maneuver the aircraft. And this was before Zeppelin could maneuver the Zeppelin. This was before the Wright brothers could fly. In fact, the Wright brothers learned about what he was doing through the papers, the American papers. They were reporting on this guy's amazing flights. And he was a coffee baron in Brazil. He was a millionaire, never went to school. He learned everything by himself. And he basically built the first laboratory in Paris to build these machines, these air flying machines. And this guy flew, and that was his dream when he was 17. It took him a decade or so, and he went to Paris and flew in front of millions of people and created the entire concept of the aeronautic industry of control flight. He basically created the control flight. And this guy is my inspiration because he never went to school, literally, never. He learned to play with machines in his father's farm in Brazil and became enamored of the idea of flying. And he decided he would fly, and he did. And this is very important and we teach our children in Brazil about this example, because it's very important to say that you are going to do something that is very daring, but it's more important to actually do it. And this is what science is about. It's this pursuit of a disillusive truth that you may never find, but you will pursue it, almost obsessively. And I think the Santos Dumont's example for our kids work beautifully, because they see planes in the skies of Natal every day, and they never actually realized that was created by a Brazilian that came from the same place that they came from, and a guy who people basically discounted. And here in America, of course, they don't recognize him because the usual American way is to put an American guy first. But the Wright brothers have left written testimony that they actually got inspired, because by the time Santos Dumont was flying in Paris, the Wright brothers were here in North Carolina, where I live, trying to work with kites, because they had no idea how to actually control their planes. And since Santos Dumont didn't believe in patents, he didn't patent anything. He published everything in the Parisian newspapers, how he was doing things. So I think he's my inspiration. Great idea. It was I saw when you guys sent me the website, I saw that it was a very interesting forum to discuss the ideas that we just talked about now. And I also saw that there were neuroscientists that had come before, so that was reassuring that I would be able to contribute something meaningful. And since my mother's family is from Lucca, from Italy, I know how good an Italian meeting can be. So